Hello learners, welcome to the course Statistical Methods for Economics, Measures of Central Tendency Part 3. In this session, we will discuss the concepts related to mode and its importance in economics, the computation of mode for different data types, identify the situation where mode is more suitable to locate mode graphically. In the previous module, we had discussed about the concept of partition values. The various partition values discussed were median, which divides the distribution into two equal parts, quartiles, which divide the distribution into four equal parts, deciles, which divide the distribution into 10 equal parts, and percentiles, which divide the distribution into 100 equal parts. As a continuation, in this module, we shall discuss the next measure of central tendency, that is mode. Mode is the value of the variable which appears maximum number of times or which appears more frequently, or the value which has maximum frequency. If the data is having only one mode, it is called as unimodal. In case the data has two modes, then it is called as bimodal. If the data has more than three modes, it is called as multimodal distribution. We shall look into the computation of mode for a raw data with the help of an example. The mode of 1, 3, 4, 5, 2, 3, 3, 6 is 3 because we observe that 3 has been repeated 3 times and other observations are repeated once or twice. Example, find the mode for the data 100, 120, 100, 120, 130, 120, 120, 130, 120, 100 regarding the wages in rupees of 10 persons. In this data, observe that 120 appears maximum number of times as compared to other observations. Hence, the mode of the given distribution is 120. Example, compute mode for the following data 4, 5, 6, 7, 8, 5, 4, 5, 6, 4, 5, 4. In this data, observe that the value 4 is repeated 4 times and the value 5 is also repeated 4 times, which means that the mode of the given data is 4 and 5. As there exist two modes for this data, we can say that it is a bimodal data. Now, we shall look into the computation of mode for discrete frequency distribution. In case of a discrete frequency distribution, mode is the value of the variable corresponding to the maximum frequency. This method can be used with ease and simplicity if the distribution is unimodal, that is, if it has only one mode. Let us understand with an example. Consider the x values as 1, 2, 3, 4, 5, 6, 7, 8, 9 and the frequency values as 3, 1, 18, 25, 40, 30, 22, 10, 6. Now observe that the maximum frequency is 40 and the variable value corresponding to the maximum frequency is 5. Hence, the mode of the distribution is 5. Let us look into another example of computing mode. Compute the mode for the following data. The x values in the given data are 10, 12, 15, 22, 25, 35, 45, 50 and 60, and its corresponding frequencies are 4, 6, 10, 14, 20, 18, 10, 6 and 3. Now, observe that the maximum frequency is 20 and the variable value corresponding to the maximum frequency is 25. Hence, the mode of the distribution is 25. Let us see how to compute the mode in case of continuous data. In case of continuous frequency distribution, the class corresponding to the maximum frequency is called the modal class, and the values of mode is obtained by the interpolation formula. Mode is equal to L plus H into F1 minus F0 divided by 2 into F1 minus F0 minus F2. Where L is the lower limit of the modal class, F1 is the frequency of the modal class, F0 is the frequency of the class preceding the modal class, F2 is the frequency of the class succeeding the modal class, and H is the magnitude of the modal class. As an example, consider the data which is the frequency distribution of the income in rupees of workers in a certain factory. Compute the mode income. The values of the income are 1000 to 2000, 2000 to 3000, 3000 to 4000, 4000 to 5000, 5000 to 6000, 6000 to 7000, and the number of workers of these income group are 15, 18, 30, 17, 18, 22 respectively. Now, in the given data, observe that the maximum frequency is 30. Hence, corresponding class 3000 to 4000 is the modal class. In order to compute the mode, the formula used is mode is equal to L plus H into F1 minus F0 divided by 2 into F1 minus F0 minus F2, where L is the lower limit of the modal class, which is equal to 3000. F1 is the frequency of the modal class, which is equal to 30. F0 is the frequency of the class preceding the modal class, which is equal to 18. F2 is the frequency of the class succeeding the modal class, which is equal to 17. And H is the magnitude of the modal class, which is equal to 1000. Substituting these values in the formula, we have mode is equal to 3000 plus 1000 into 30 minus 18 divided by 2 into 30 minus 18 minus 17, which is equal to 3000 plus 1000 into 12 divided by 60 minus 18 minus 17, which is equal to 3000 plus 12,000 divided by 25, which is equal to 3000 plus 480. which is equal to 3480. Hence, the mode income of the workers is in a factory is rupees 3480. Let us consider another example for the computation of mode. Calculate mode for the following data. The values of the class interval are 0 to 3, 3 to 5, 5 to 7, 7 to 10, 10 to 13, 13 to 15, 15 to 20, 20 to 25, 25 to 30. And the values of frequencies are 2, 3, 5, 5, 15, 5, 7, 5, 3 respectively. Now, observe that in the given frequency distribution, the class interval is with unequal class width. Hence, before computing the mode, it is necessary to make them to equal class interval. So, let us first tabulate the data. Consider the class interval in the first column and the frequencies in the second column. In the third column, compute the width of the class interval. The width is given by upper class limit minus lower class limit. Hence, the values in the third column are 3, 2, 2, 3, 3, 2, 5, 5, 5. As the maximum width is 5, let us combine the classes with width less than 5 to make them of equal class intervals. Combining the class intervals, the new classes would be 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. And the corresponding frequencies would be 5, 10, 20, 7, 5 and 3. Now, in the pooled data, observe that the maximum frequency is 20. Hence, corresponding class interval is 10 to 15. Hence, corresponding class interval 10 to 15 is the modal class. In order to compute the mode, the formula used is mode is equal to L plus H into F1 minus F0 divided by 2 into F1 minus F0 minus F2, where L is the lower limit of the modal class, which is equal to 10. F1 is the frequency of the modal class, which is equal to 20. F0 is the frequency of the class preceding the modal class, which is equal to 10. F2 is the frequency of the class succeeding the modal class, which is equal to 7. And H is the magnitude of the modal class, which is equal to 5. Substituting these values in the formula, we have mode is equal to 10 plus 5 into 20 minus 10 divided by 2 into 20 minus 10 minus 7, which is equal to 10 plus 5 into 10 divided by 40 minus 10 minus 7, which is equal to 10 plus 50 divided by 23, which is equal to 10 plus 2.17, which is equal to 12.17. Hence, the mode of the given data is 12.17. In the process of computation of mode, certain points are to be noted. They are: the frequency distribution must be continuous with exclusive type classes without any gaps. In case if the data is of inclusive class intervals, then it has to be converted into exclusive class by the concept of class boundaries. The class intervals must be uniform throughout. That is, the width of all the class intervals must be the same. The above formula for the computation of mode is not suitable under certain situations, which are as follows. If the maximum frequency is repeated or approximately equal concentration of data points is found in two or more neighboring values. If the maximum frequency occur either in the very beginning or at the end of the distribution. If there are irregularities in the distribution. However, if the irregularities of the class intervals can be made equal by pooling them, then the mode can be computed. In such situations, we say that mode is ill-defined and we may use pooling method or grouping method in order to compute the mode. Empirical relationship between mean, median and mode. In case of a symmetrical distribution, mean, median and mode coincide. That is, mean is equal to median is equal to mode. For a moderately asymmetrical distribution, mean and mode usually lie on the two ends of the distribution and median value lies in between them, and they obey the following important empirical relationship, which is mode is equal to mean minus 3 times mean minus median, or on simplification, mode is equal to 3 median minus 2 mean. Let us look into the example to compute mode by applying an empirical relationship. In a slightly skewed distribution, mean and median are 33.18 and 33.33 respectively. Find mode. From the given information, we have mean is equal to 33.18. Median is equal to 33.33. Hence, mode is equal to 3 median minus 2 mean, which is equal to 3 into 33.33 minus 2 into 33.18, which is equal to 99.99 minus 66.36, which is equal to 33.63. Hence, mode for the slightly skewed distribution with the given values of mean and median is 33.63. Now, we shall look into the graphical location of mode. Mode can be located graphically from the histogram of frequency distribution by making use of the rectangles erected on the modal, pre-modal and post-modal classes. The method of obtaining mode graphically consists of the following steps. First, identify the tallest bar in the histogram, which would be the modal class. Then, join the top right corner of the rectangle erected on the modal class with the top right corner of the rectangle erected on the preceding class of the modal class by means of a straight line. After that, join the top left corner of the rectangle erected on the modal class with the top left corner of the rectangle erected on the succeeding the modal class by means of a straight line. Then, from the point of intersection of the diagonal lines obtained by connecting the top corners of the model class, draw a perpendicular line to the x-axis. The point where this perpendicular line meets the x-axis gives the modal value. Let us understand the location of mode with an example. The data is a frequency distribution of weights of a group of 60 students of a class in a school, where the weight in kilos are 30 to 35, 35 to 40, 40 to 45, 45 to 50, 50 to 55, 55 to 60, 60 to 65, and the corresponding number of students are 3, 5, 12, 18, 14, 6, 2. We have to locate mode graphically. As the first step, construct the histogram as discussed in Module 3. Now, observe that the bar with the maximum frequency is in the class 45 to 50. From the left corner top of the maximum frequency bar, draw a diagonal line to the left corner top of the succeeding bar, and from the right corner top of the maximum frequency bar, draw a diagonal line to the right corner top of the preceding bar. From the point where these two diagonal lines intersect, draw a perpendicular line to x-axis. The corresponding value in the x-axis is the modal value. From the graph, it is observed that the modal value is 46. Now, let us look into certain merits and demerits of mode. Merits of mode. In some cases, mode can be merely located by inspection. Mode is easy to calculate and understand. Mode is not at all affected by extreme observations. Mode can be estimated graphically by the construction of histogram. Mode can be conveniently obtained in case of open-end classes. Demerits of mode. Mode is not rigidly defined. That is, it may be ill-defined. Mode is not based on all the observations. Mode is not suitable for further mathematical treatment. Mode is affected to a greater extent by fluctuations of sampling. Certain points are useful in the interpretation of mode. They are: for a positively skewed distribution, mean will be greater than median and median will be greater than mode. And for a negatively skewed distribution, mode will be greater than median and median will be greater than mean. Summarization. In this session, we have discussed about the concept of mode, how mode can be computed for raw data, discrete data, continuous data, and how mode can be located graphically with the help of histogram. Also, the merits and demerits of the mode has been discussed. Thank you.